Two different things on Coursera absolutely changed my life. Machine learning by Andrew Ng and deep learning specialization by Andrew Ng. The first one is a course. The second one is a specialization, which is made up of many courses, although one of those courses is probably smaller than the main course here in the machine learning one. So Andrew Ng is an absolutely phenomenal teacher, and these are incredible options. Either one you can start with. You could start with deep learning or you could start with machine learning. They do not have so much overlap that you can't do both. I think both is worthwhile. If I was to start with one, I'd probably choose machine learning just because it would make you learn the deep learning stuff, understand it a little bit better, but you could start with either. Now, the machine learning one is a course, and so it's definitely going to be cheaper if you want to get the certificate. By the way, every employer knows the certificates. I have links in the description if you want to pick one of those up. Now, skills you will gain: logistic regression, neural networks, machine learning, and machine learning. So they're just putting various keywords, except so that looks kind of limited if you compare it to the skills over here. Transformers, so this is updated. Actually, I haven't taken the updated one, but it's even better. Transformers, deep learning, backpropagation, Python, neural network architecture. So many other terms here. Recurrent neural network are the big ones. So CNN, RNN are the really two big ones, as well as just kind of deep learning in general. So why would I choose one over the other to start? Well, first of all, machine learning, I would start with this because it gives more of a basic statistics understanding of what's going on under the hood, and it's practical for training all of the various different models, regardless of what is going on here. Deep learning, based neural network, recurrent neural network, whether you're doing it in Python or R or in TensorFlow or in Keras or whatever the heck you're doing it in, you're going to understand what you're doing a lot better with the theory in the machine learning one. And that is due to, if I go to the syllabus, first of all, it's going to give you a base understanding of the different types of machine learning, which is very helpful. But once you get through this really basic stuff, you're going to understand linear regression, which is really what a neural network does, except it does this many times, or they change it a little bit when it gets more complicated. But that's basically the idea, is a bunch of different logistic regressions or kind of non-linear regressions. So then linear algebra, and you got to understand this stuff if you want to know the inner workings of machine learning. If you don't want to understand that stuff entirely, then you can skip this, but you get really limited unless you go through it. Linear regression with multiple variables. Octave / Matlab tutorial. Okay, so this is a big one. You probably don't even know what Octave is. Matlab you may have heard of. Basically, Octave is free Matlab, and so MAT stands for matrix, or MATLAB stands for matrix laboratory. So they're choosing MATLAB because it is fundamentally linear algebra, what's going on. Pretty much everything is a matrix or a vector or one of these things. And so all the machine learning stuff relies on this linear algebra. So it kind of makes sense to do it in MATLAB. Whereas opposed to Python, you have all these different data types like strings, blah, blah, blah. You need to import libraries for doing stuff like linear algebra with NumPy or TensorFlow or something like that. And so it's based in the language to do it in MATLAB, except it's obviously not as popular a programming language. So a lot of people are rightfully annoyed that this course is not in Python, and I kind of get that. But that's totally okay, because I would do the assignments anyway in MATLAB, or you could probably end up doing them in Python if you converted it yourself. But it's not as big a deal as you think, because it's mostly for understanding and not for applying this type of thing. And hence the deep learning one is a little bit more applied. The projects that you're going to do in there are a little more up to date, as in modern techniques of solving various cool problems like in computer vision and natural language processing. Okay, so once you get through all these base stuff like regression, logistic regression, it's all really important. Regularization is a technique for, that comes up in neural networks as performing regularization, but again, just a base way of doing this, which is essentially just a form of solving the overfitting problem, which they're going to talk about in these sections here. I would assume regularization is, so the problem of overfitting. This is for training any type of model, is really important to understand the stuff, cost functions, and they do kind of explain that in the deep learning, except you understand a lot better if you go through this course, in my opinion. So I would highly recommend doing that if you can. And they do talk about neural networks, of course, because machine learning modernly kind of implies neural networks, except they're not going to go through the really modern stuff. Is they're going to explain in the deep learning specialization over here is what a CNN does, which is very important for computer vision and a couple other things. And recurrent neural networks, which is very important for natural language processing or time series modeling. They're going to go over the applications here and theory behind those applications, except machine learning, they're from a really base standpoint, it explains everything that's going on, and so I still would recommend doing this beforehand. Support vector machines, you honestly could probably skip. It's a little bit out of date and not necessary to learn, in my opinion, although it obviously wouldn't hurt. It is still helpful. It goes through unsupervised learning, which I don't believe the deep learning specialization goes through at all. At least I don't think it did when I did it. There's really no need for it. All these neural network type things, they're doing supervised learning, so they're not even really going to touch upon that topic. Dimensionality reduction is, something extremely important in practice. You're gonna have to understand when you're actually dealing with variables, how you might structure this to get the model that you really want. And then more, general applications, detecting anomalies. Recommender systems, they're not going to talk about that in the deep learning specialization, even though this is essential to, Netflix, Amazon is giving you the right video or the right product. They're super important. Large scale machine learning, I think they might have updated it a little bit since I've done this. Oh, okay, no, this stuff. So understanding what gradient descent is, which is really just how a neural network or many different types of algorithms train and learn their parameters. And then there's an example problem at the end with a photo. Okay, so very good course, machine learning here. You're going to understand all the basics. And the deep learning, if I was to go through that syllabus, which, right, it's a course now, or multiple courses. So base neural networks, improving these things, structuring machine learning projects, which I honestly think you could probably skip, but it's still really helpful. Convolutional neural networks, if you want to learn about computer vision, you have to do this. I found it really exciting. And even just for a simple machine learning app, it's a nice way to move ahead of other people, is to learn convolutional neural networks, because they're not all that different than a normal neural network. They are, because they have a specific name, but it's pretty easy, in my opinion, to understand why they're doing these types of things and the structure behind it, so that it solves the problem that it's well suited to, which is with pictures. It made sense to me when I learned it, at least with the way Andrew Ng teaches it. It's really good. And sequence models is, sequence just means like a time series, so it's changing value over time. So maybe demand forecasting, watching the price of apples over time, trying to predict that, or a sentence changes over time, so that that references natural language processing for sure. And it says it right there, NLP, machine translation, chatbots. So really good stuff. They are both absolutely amazing courses. And if you have, every employer knows these things. So if you're trying to improve your portfolio, then, putting this on your LinkedIn wouldn't hurt. Everyone knows it. And just learning the content is essential. So there's the difference between the two courses. I hope you found this valuable. Please subscribe if you're not, and I'll see you in the next video.